Good evening. Is it audible? Just send thumb or in reply in message. Is it audible? Okay. Thank you, Manohar. My screen is visible. Anyone can respond. Okay. Thank you, Arshita. So we have the last class we did about what do you mean by singly linked list and what are the types of linked list we have. That is the content. I am just refreshing about what we did last class. We thought about what is linked list and what are the different types of linked list. We have one common question in the exam paper. Everyone has to be remember. So what is linked list? Linked list is a non-primitive data structure. It have a two field. One is called information field. Another one is called the link field, and both the node, it is also called as a node. The node will contain both information and link, we call as a list. And so we get a common question in the exam paper: what is the difference between array and linked list? What is array and why you are going with the linked list? The array is the static data structure, but linked list is a dynamic data structure, and that once the memory is allocated in the array, it cannot be modified during the execution of the time, but memory allocated can be modified during the execution of time. That is the dynamic thing. The memory allocated may be overutilized or underutilized, can be happen. Like for example, a is equal to 10, I'm defining, I want to add 12 elements, that is good, and that is also not possible if you have only one element and wasting for the nine the space in that array. Memory allocated need not be contiguous, it's not like that. And is it contiguous? It is not contiguous. The accessing arbitrary element is easy, but accessing arbitrary element is time consuming because I have to traverse the list one by one, including the information as well as the address of each corresponding node. The next we have insertion, deletion of operations are time consuming because a shift is overhead. But here insertion of any element or deletion of operation can easily done by rearranging the list by giving the address between the previous node as well as the current node. So apart from this is the one common everyone need to prepare for the exam. What is the difference of array and linked list? Once I know the difference of the array and linked list, what are the types of linked list we study? So we already know singly linked list. What is singly linked list? As the name indicate, I have only one pointer has to be pointed to the towards the right side. So I have the node. The node will be contain information, and the second field is called link, or we call the next. See, it will contain the address of the next field where I have to point it. That any node will be ending by the link field has to be written as a null. It indicates the end of the node. It can have any number of node, but the last node will be pointing with the link field as a null character. Each node contains the address of the next node, and the last node of the link field is the null to indicate the last node of the list. And traversing can be possible only the forward direction. The forward direction is once I have to start with the 30, next I should be go for the 12, and next I should be go for the 45. The like that only traversing. The traversing is nothing but display the content of the list. Okay. Either will be asking traversing right there, a programming code for the traversing, or I can go for the display the content of the list. So both are same. Or any further node can be reached from the current node. So it can, whatever the red line will be indicate this is the current node. From the current node, I can move to finding any of the node from the right side of the linked list. And it consumes less memory compared to the doubly linked list. So what is doubly linked list? As the name indicate double. There are two pointers should be pointing in that node. So what a two pointer? This is my doubly linked list. There are three fields are there. Yesterday we did. There are three fields. And in this, the middle of the field have information, and the information of the left is left link and the right is right link. So if in case in the doubly linked, this is the first node. Observe the first node is represented by using the red color pointer. This is the first. Whenever I made this is the first. The left link for the first node always null. So whenever the left links, there is that I'm not pointing to the any of the previous node. It is pointing with the left node. It is called the first node. And the right side, we have a linking to the next neighboring above the node. So the R link will be contains the address of the next. This is the current. The R link will be contains the address of the next node. Okay. Again, I have another second node. The second node we have a two pointers. You observe. So this information is 12. So I have a two pointer. One pointer we call the R link. The second pointer is called the L link. The L link will be contains the address of the previous. So whenever I'm taking this as the current. So this is the current. Observe. So there are three types of pointer or three types of names are using today's class. So one we call the current. The current is whatever I am looking into the node. Then we have with respect to the current, I am talking about the previous. The previous is called the whatever that the left side of the node. Whenever I'm talking the middle as the current, the previous we call the left side. So I have one more keyword I am using for the next. This is the current. So this is the previous and this is the next. So with respect to the current, the next is always forward to the right side of the node. Previous, current, next. Previous is the hold, current is the actual execution mode. The next is the after the current which has to be executed. So that is the next node. So this middle I have a two pointer. One is the R link. R link will be contains the address of the next and L link will be contains the address of the previous node. So this is that representation of the doubly linked list. So one more thing you need to identify in the doubly linked list, the last node always the R link will be represented as the null. So this is already discussed about the previous class. The R link we have a null that indicate that all the nodes are ended. It indicates the end of the linked list of your node. So each node contains the address of the next node as well as the address of the previous nodes in the list. So what is the first node? The first node of L-link field is a null to indicate the first node in the list. This is the null. The last node R-link. See, observe R-link. The R-link field is a null to indicate the last node of the list. As well as we have a traversing is possible in the both forward and backward direction in doubly linked list. Because in a singly linked list, I can only do only one direction to that one. And any successor node or any predecessor, this is the previous and the next, can be reached through the current node. I have to take this is the current node. From the current node, I can move toward the successor 45. From the current node, I can go for the predecessor 30. I can move towards left, move towards right also. Yeah, but it consumes more memory compared to singly linked list because it pointing to two pointer. You should be know what is doubly linked list. If you explain define doubly linked list and pictorial representation, you need to write this and you need to list out these points. So what about next? What is circular singly linked list? So this is my circular singly linked list. So as I have it is look like a singly linked list, but I already explained what is circular queue. So what is the that is the same as circular queue. So the last point, so instead of the last node containing the null pointer, it will contain the address of the first node. The circular is nothing but the last node will be contains the address of the first node. See that we call as the circular singly linked list. See I have a three nodes are there. The first node is 30, second node is 12, third node is 45. The third node is represented with the red color arrow mark is the last. The last node will be contain the address of the first node. It is not a null. So then we call as a circular singly linked list. So you need to know circular singly linked list. What do you mean? Each node contains the address of the next node in the list. Second point, the last node link field contains the address of the first node of the list. Traversing is possible in only forward direction. See, I have to towards the right. I don't have a two arrow mark, only the one arrow mark towards the right side, only one direction. Any further node can be reached from the current node. I can visit any node by using the current node. You can take any node as a current node. So whichever you are taking the current node, from the right side, you can access it towards that. See that we call circular linked list. So next we have circular doubly linked list. Singly linked list done, doubly linked list done. Third one is circular singly linked list done. Fourth one, circular doubly linked list. See, what is circular doubly linked list? As the name indicates, circular is there. The last node will be contains the address of the first node. The same thing, the first node is also contains the address of the last one. Because the doubly linked list, I have a two pointer. Observe, there the two red arrow marks are moving towards left, moving towards right. See, this is my 30 is the first node. The first node, the information is 30. It contains both R link and N link. Normal doubly linked list, L link has to be null and R link has to be null. Because the R link null, it indicates the end of my node. The L link have a null, it indicates the first of the node. But so whenever the name has circular doubly linked list, it will contain the first L link. The first L link, it contains the address of the last node, and the last one will contain the R link will be contains the address of the first one. See, this is the pictorial representation of circular doubly linked list. Each node contains the address of the next node as well as the address of the previous node. The first node L link field contains address of the last node. See, the first node L link will be contains the address of the last node. The last node R link, observe this is an R link, contains the address of the first node. See, that will be moved towards like this. Traversing is possible in both forward direction and backward direction. Okay. Any successor node, that is the front, any predecessor back can be reached from the current node. I think now you got the clarity between singly linked list, doubly linked list, circular singly linked list, circular doubly linked list. Any type you can ask in the exam, all four are included in your syllabus. And we are already discussed in the last class how to represent a creation of a node. I have to using structure. I can also using get node function to creating any one of the node. See, this is I am creating a node using singly linked list. The singly linked list, I have only the two field. One is the information field. The second one is the struct node of star next. So the star next, because I'm creating a pointer to that, so the dynamically memory location I'm using any number of nodes can be created for that one. So because of that, the struct node, I am creating that the variable of the structure as a node. Using this node, I can accessing any number of the nodes with these the members of the structure. A structure containing a members in which a pointer to the same structure type is referred to as self-referential structure. See, this is the struct node. I'm creating a star next. The star next is a variable will be accessing the same structure. Structure containing a member which is a pointer to the same structure type is referred to as self-referential structure. Then how can we allocating a memory for a node in a singly linked list? That is called dynamic memory allocation. So how to do for the dynamic memory allocation for the singly linked list and doubly linked list? All are the same way of representation. I have to use malloc function for any of the singly linked list or for the list for the allocation. See, yesterday we discussed about we have to use get node function. There are two types of nodes are available. One is the get node. The second one is the free node. Everyone should be know what is the use of get node. To creating a node in the linked list, we call a get node. So how many number of get node and how to allocating a spacing for the get node, I have to use a malloc function. See, once the process has to be done, I have to remove from that one. I have to use a free node. Get node is a function. Free node is a function. Those things I have to use it. The node star get node, I have to create a one temporary variable for that one. So I have to allocating a space for that node with the malloc and size of the node, how many size to be required for these two. So that number of size will be allocated for that variable and return that node. See, this is for the how to allocating a memory space for that. I am not adding any information into the linked list. Just I am allocating memory through that get node. Then once I am allocating, I can also the free my node. Freeing a memory for a node in a singly linked list can be called by using the free node. The free node, which one I have to free? The temporary is my node name. I have to free that by just calling a function free for the corresponding name of the. So these two functions are using to how to allocating a memory, how to deallocating the memory through dynamic memory variable for the singly linked list. So when I talk about the linked list or anything, what type of operations can be done? See, we already discussed what type of operation can be done. We have a different types of operation for that one. See that we have creating a linked list, traversing a linked list, inserting an item into linked list, deleting an item from the linked list, searching an item into the linked list, merging of two or more linked lists, reversing a linked list. It's like that there are different types of operation can be done. So we are already discussing about how to inserting an element to the linked list. That there are three variety of should be there. Either I can inserting a element into the linked list from the beginning. See, basic operations on a single list. So there are the different varieties. One is inserting a new node at the beginning of a single list. So what is the beginning of the single list? I have to explain about. See, this is one. I have a list. So this is the list. The 99 has to be added before the 15. So whenever I am showing the before the 15 for this, so this is called inserting a node at the front or beginning. So if in case this 19 has to be added after the 47, see that is called ending or rare end. Or that end of the list. Either you can add with the beginning or I can add with the ending. See how to do it. I already explained about this. Whenever to adding that one, I have to call a get node function. So once the get node function I am getting, I should be add information into that. That is an item. 99 is to be added to the information queue, and that I have to give the pointer to this as a first. The next of queue, because this is the next of queue. This is the queue. Next of queue has to be represented for the first of this. Whatever the first is mentioning of the 15, this link has to be added to this. See, once I got the link with the dotted line, then I have to make the queue has to be first. Because of that, that queue has to be making a first. Then once I'm assigning, I have to return the first. This is called inserting a node into the queue. The same way how to doing. Say I'm creating a node. I'm calling it int first. So this is how to adding through dynamic memory allocations. Here I am not taken any part of dynamic memory allocations, just without doing I am adding. Only the difference between the dynamic and static. If the dynamic allocations are adding, then you have to use the malloc function of that. That's all. So you have to add the malloc function for the which variable, adding queue of info with the item, queue of next is equal to first. I am making that first has to be whatever I am created the queue that has to be doing. So this is inserting an element to the front. The same thing I am written here also. Creating a new node. The new node malloc I have to call the data. Either that is a data is 99, I'll be added to the new node of info, and the new node of next I have to set with the first, and the first has to be get returned. What is the value I'm inserted, that can also print it and return the new node, that is queue has to be ended. The next we have inserting a new node at the end of the singly linked list. See how to add an element at the end of a singly linked list. See this is the position. So I can do inserting a node at the last, or we call it rear end. So what is the rear end? This is my linked list already I have, but I have a 47, there is a null. After 47, I need to insert 99. See, this is the my part. See, I have to get here 99. What are the changes has to be required? First, I need to take a get node. The first steps I need to take a get node. See, before I am adding this 99 to the 47, I need to check. See, any nodes are present there, or there is no node. That is only the first node. I can return this as the first one. That is a one possible. If the first there is no first, the first node is only the null, then I can return whatever I'm creating this queue has the first node. Second case, I have some elements. I need to move towards the right direction. I have to check the right direction of the link field. See, this is the link field. This is my current. The current of the next field is null. No, it have some pointer. The 12 is the next current node. The current of next field is null. No, it is not. 47 should be. The current of this next field is null. Yeah, whenever I have a null, I have to make this null. I have to give the address of the queue. So I have to set this queue to this 47 location. That modification has to be done. See, first before doing, I want to create a new node by using a get node function. Create a new node of the info. I have to get 99. See, I have to search through current pointer. This is, I am taking from the first. I'm starting with the current. The current of next. This is the current of information. The current is the 47th location. Current of info is 47, but current of next of current. See, what do you mean by the next of current? This is the next node. The next of current, I have to give the link to the temporary variable. This is my temporary variable. So once I give the temporary variable, then I have to give that proposition. I have to return. This is the first as in null. Then what is the temporary variable next? That has to be assigned with the null character. See, null next of null will be assigned. See, let me observe what is that one. I have a current. First, I have to check observe here. I have to create an algorithm for the rear end. I need to give the first position and the item. I have to call a get node function, which item need to be inserted. See, my list is completely empty. There is no list are there. I'm checking if first equal to null. This first is null. So I don't have any list. Then I can set whatever I'm creating. This get node has the first node. See, because of that, return first, or else I am taking the first node will be making as a current node. I have to take this first node as a current node because I have to search where is the null pointer in the right side. I want to check this null pointer. I have to move towards the right. One by one node I am checking. See, that can be done by using put the condition next of current. See, this is I am taking the current. Next of current is this pointer. This is the pointer. This is the next of information. This is the next of current. Is null. I have to check by UIL. Next of current not equal to null. Why I am doing? To find the last node of the address, I have to checking. Then I have to follow the next of current is occur. And I have to follow whenever I'm getting the null, I have to create a get node. So when the get node item has to be inserted in the info part and give the after item I have to give that null because of the next of cur I have to mention the temp. Next of q has to be mentioned with null. This is the null I'm adding. This null can be added by using next of q is null. This is the q. Assume this is the q. Next of q has to be set by null. So after setting, I have to return this first because the first I am not changing the first pointer. The return the first. So this is the case how to adding the node at the rear end. See, this is I have to get it. See, that is the C programming part. Same thing. I have to give the malloc function. So whatever I'm explaining, the same process I am doing. The current of next not equal to null. Do the checking for the next item current of next. The current of next whenever I'm getting you have to set this q value and return the first. So third condition, insert at specified position. See, I have to do for inserting at last node is done, inserting at the beginning is done. See, you can do the deleting at the first node or deleting at the last node. See, that can also doing, and before doing the deletion operation I will take how to inserting at the specified position. So what are the specified positions? I will end my link right now because I have 5 minutes are left out. I will continue with the next link. You can join the next link for the continuation of this. Just I will share the link. Everyone can be joined that link.